Okay, hi girls. So we're going to work our way through the different IR spectrum that I taught you about yesterday. So for today's lesson, what you need to do first is you can ask the teacher to pause the video and this video that I'm presenting, and then you can cut up your IR spectra to each individual molecule like that, like what I've done. All right, and so you should have a pile of those that are cut up. The next thing I want you to do is, after you've cut them, I want you to write down the molecular formula for each of those molecules. So for example, propanone, the structure is given to you, which of course you won't be given this in the exam. What they'll just tell you is that it is C3 hydrogens, 6 and 1 oxygen. All right, so I want you to do that for each of the IR, the spectra that I've given you. All right, so pause the video, cut, and you don't want to take too much time for that, because remember, the assessment is not on how well you can cut. So really quickly cut it up, and then let's start by writing the molecular formula for each of them. All right, so when that's ready, you can ask the teacher to just unpause the video and we can continue. The first molecule I'm going to talk to you about is propanone. All right, so when you've cut it up, take your data sheet that I gave you yesterday. Now there may be some who are in class today who were not in class yesterday. If you haven't got this data sheet, I'll try and leave some on the teacher's table. Otherwise you can just share and I'll give it to you. All right. So propanone, I know that because it is 3 carbons, 6 hydrogens and 1 oxygen, that this could be either an alcohol or it could be an aldehyde, because that's the other functional group we learned that has 1 oxygen, or it could be a ketone, right? Okay. So what I now need to do is I need to I've shortlisted of all the different functional groups that we know. This IR spectrum relates to either an alcohol, an aldehyde or a ketone, and I've arrived at that conclusion just based on the molecular formula that they will give you in the exam, which shows that there is 1 oxygen. All right. Now let's go and interpret the IR spectra. So remember, your IR spectra is a plot of transmittance, which is on the y-axis, and wave number, which is per centimeter, which is on your x-axis. These are called peaks. All right. This one would be a narrow, sharp peak, whereas that peak there I would call as a broad, not at all a strong, not so strong peak. Okay. So pull out your data sheet and look up what will you be identifying. If it was an alcohol, there would be a stretch or some sort of peak between 3200 and 3600. Okay, so 3200 is there. That's 31, that's 32, okay? 3200 and 3600, I don't have any significant peaks over here. That is not so significant, so I can pretty much rule out that this is not an alcohol. So that just leaves me with the next bit on the data sheet that says that if it's not an alcohol, then I'm looking for the next possible option, which is aldehyde or ketone. So I'm looking for a C double bond O stretch. So that carbonyl group actually goes through, remember there are 2 vibrations, stretching or bending. So this one at this particular wavelength is stretching, and it is between 1670 and 1780. So have a look and see if we do have some activity in that area. Yes, we do. So I would, you can glue this into your books and probably just draw an arrow and say that that is the C double bond O, which is between 1670 to 1780, and don't forget the unit. Okay. And the other one I would say is I need to talk about peaks that are absent and peaks that are present. So I will say, because I need to justify that it's not an alcohol, I will say there is the absence of the OH stretch between 3200 and 3600 per centimeter, and I get that from the data sheet, so just copy that there. So remember, why am I talking about that? Because I thought it could be an alcohol or an aldehyde or a ketone, but now I'm definitely saying the absence of this stretching peak between 3200 and 360 per centimeter says that it's not an alcohol, so it is rather a group that has a C double bond O, which could be an aldehyde or a ketone. Now, in this case, we know that it is a ketone simply because they already told us that. But the reality is that for every molecule that you get in the exam, you will be given IR, you will be given NMR, and you will be given mass spec. It is impossible to actually fully identify a molecule using just IR. And one reason is that, for example, there's nothing significantly different between an aldehyde and a ketone, because they both have a stretch in the same area. So using IR, that's all you can do. You can narrow it down to either an aldehyde or a ketone. But look at your data sheet here. When I go on to NMR, which is another sort of spectrum, then definitely you have a difference between a CO in a ketone and a CO in an aldehyde. So they are found at two different areas of that spectrum. So what I'm saying is that with using IR, you're only able to narrow it down to the fact that it's either an aldehyde or a ketone, but then using NMR, you can be more specific and say that it's exactly an aldehyde or a ketone, depending on the spectrum provided. Okay, so that's our first one. Well, let's go to the second one. So when you're writing the answer, all I'm going to do is need to talk about the groups that are absent. So you must discuss groups or peaks that are absent as well as the ones that are present. Okay, so we discuss groups or peaks that are absent as well as the ones that are present. So for this particular molecule, I will say that there is the absence of an OH stretch between, so I'm just using the words that they provide on the data sheet. I want to say that this is absent, so I say that's an OH bond, that is a stretch, that's already given to us, so I'm just borrowing information from the data sheet. And between 3200, you always write the smaller number first, and 3600, and you must always give the unit its per centimeter. Confirms it is not an alcohol. The C double bond O stretch between a C double bond O stretch between 1670 to 1780 per centimeter confirms it is a ketone. Alright, so you can see this so do it in this that I have, look into your exercise book, and then you can make some marks on this, but you're not going to get graded like if you do this in the exam, so you need to give a little more detail, and that's what I did. So you can ask the teacher to pause the video, and then you can copy this down. Alright, the next molecule I'm going to look at is propanol, which is an aldehyde. Alright? So I'm going to go and write down its molecular formula because that's what is given to us. See, there are 3 carbons. How many hydrogens are there? 5, 6 hydrogens and 1 oxygen. Alright? So that's what will be given to us. Again, using the molecular formula, you can say that it's either an alcohol or an aldehyde or a ketone. Right? Okay, so if it was an alcohol, according to our data sheet, we must have the OH stretch between 3200 and 3600. So I go and look at between 3200 and 3600, I have no activity on this. So I could just put an arrow and say absence of OH stretch. So you first narrow down to which group, functional groups it could be, then you talk about the absence of, you're kind of ruling out possibility. So it's definitely not an OH group, but what you do have is this very strong peak that you have around 1,7 or 1,8. So that corresponds to the C double bond O stretch, which is 1,670 to 1,780. So that corresponds to the C double bond O stretch. Alright, so again your answer would include that we've eliminated that it's definitely not an alcohol. It could be an aldehyde or a ketone, and that's because it is C double bond O stretch. You can actually just say very specifically that this is an aldehyde only when you have the NMR spectrum also provided. So you will be given for every molecule IR and NMR as well as mass. Alright, so this will kind of help you to narrow down the functional groups. NMR will help you to actually eliminate even between the options that you've narrowed down to, and mass spec will help you to find how the molecule is put together or structured. Okay, so this one's definitely is an aldehyde or a ketone. In our answer, we know the amount of data we have is just this. We know that it's an aldehyde. So how do we write this answer down? So glue this into your exercise books, and then you can say that there is the absence of the same words that I take from the data sheet here. The OH group, the OH stretch between this is missing. (3200 to 3600 per centimeter) confirms it is not an alcohol. Okay, but how do we describe this peak? This is a strong narrow peak at between this range. Okay, between 1,670 and 1,780. So, but the presence of a strong narrow peak between, so take your data sheet and just copy C double bond O stretch between 1,670 to 1,780 per centimeter confirms a C double bond O stretch, and that is could be an aldehyde or a ketone. Could be an aldehyde, alright? So in this case it is an aldehyde, it's propanal. Alright, so remember again, without the NMR we can't specifically say confirm it, but in this case I'm just going to stop with that. Okay, so we have covered what a IR spectra for a ketone looks and what it looks like for an aldehyde. And both of them, what is similar to them is this C double bond O. Because in a ketone, you have CR, C double bond O, and then R dash. So that is a ketone. But an aldehyde is R, C double bond O, and then hydrogen. So what is similar is this group for both of them, and that is what you see as a very strong narrow peak between 1670 and 1780 per centimeter. That is a C double bond O stretch. Alright, so those two are over. We move on to the next one, which is propan 1-ol. Again, I would not know this. What I'd be given in the exam is just the molecular formula. So that's 1, 2, 3 carbons. How many hydrogens do we have? 1, 2, 3, 4, 5, 6, 7, and 8 hydrogens, and you have 1 oxygen. Alright? So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. 3 carbons, 8 hydrogens, and 1 oxygen. Again, it could be an alcohol, it could be an aldehyde, or you could have a ketone here. Okay? But there's something very prominent in this spectra that we did not have for propanal or propanol. Propanone or propanal. Can you tell me what that is? Okay, so compare these two. This was our ketone. This is the first one we did, and this is the second one. Okay, first we did this. So that's the one we're doing right now, propanol, propanone, and they're similar. These 3 groups are similar because they all have 1 oxygen. That's an alcohol, it has 1 oxygen. That's a ketone and it'll have 1 oxygen. That's an aldehyde, propanal, and that'll also have 1 oxygen. But what is different in the IR spectra is you notice straight away this broad peak at around 3200. That confirms that that is an alcohol. You do not have that for a ketone, you do not have that for a aldehyde. Again, another very defining factor or something different between these 3 groups is that you have a C double bond O stretch for the ketone, you have a C double bond O stretch for the aldehyde, but you do not have it for the alcohol. So there's a presence of a broad peak confirming that it's an alcohol, but there's the absence of the C double bond O, so it definitely cannot be a ketone or an aldehyde. Okay, so let's go and write down what is absent. So we rule out what is not, what it cannot be is there is the absence of the C double bond O. What does the data sheet call it? It's called a C double bond O stretch between